In the evolving landscape of cybersecurity, organizations often prioritize firewalls, antivirus solutions, and endpoint protection. While these measures are vital, an equally critical yet frequently underestimated component demands attention. The domain name system, DNS. As the backbone of nearly every online interaction, DNS is not merely foundational. It is a prime target for cyber adversaries. Unsecured DNS infrastructure represents a single point of failure capable of disrupting operations, redirecting users to malicious destinations, or compromising sensitive data. Robust DNS security is not optional. It is a cornerstone of a resilient cybersecurity strategy, the foundational role of DNS in digital infrastructure. The domain name system serves as the Internet's directory, translating user-friendly domain names, e.g., example.com, into numerical IP addresses, e.g., 192.0.2.1, that enable devices to communicate across networks. Every online action, whether browsing a website, accessing an application, or sending an email, initiates a DNS query to locate the appropriate server. Without DNS, users would face the impractical task of memorizing complex IP addresses for every digital destination. Operating seamlessly in the background, DNS is indispensable to the modern Internet experience. However, disruptions or compromises to the system can cascade, rendering services inaccessible and undermining user trust. Why DNS is a high-value target for cyber threats. At first glance, DNS may appear as a benign utility, quietly resolving domain names to facilitate seamless Internet navigation. Yet its ubiquitous role in every online interaction makes it an attractive vector for cyber attacks. DNS is integral to virtually every click, connection, and data exchange, positioning it as a critical leverage point for malicious actors. Originally designed for functionality rather than security, DNS often transmits unencrypted and unauthenticated queries, rendering it vulnerable to exploitation. This lack of inherent security allows attackers to execute sophisticated, high-impact attacks that evade traditional defenses. Common DNS-based threats include DNS spoofing, manipulating DNS resolvers to redirect users to fraudulent websites that mimic legitimate ones, DNS hijacking, altering DNS records or configurations to route traffic through malicious servers, DNS tunneling, concealing exfiltrated data within DNS queries to bypass firewall protections, distributed denial of service, DDoS, attacks, overloading DNS servers to disrupt access to websites and services. These attacks can cripple organizational operations, compromise confidential information, or enable covert surveillance. As such, securing DNS is not merely a best practice. It is a critical line of defense. Proactive defense through DNS security. Securing DNS enables organizations to neutralize threats at their inception before they infiltrate internal systems. By actively monitoring and filtering DNS traffic, organizations can identify and block malicious activities early, reducing the risk of compromise and providing critical time to respond. DNS security transforms the system from a passive utility into a proactive security asset, functioning as both a sensor for detecting anomalies and a shield against threats. DNS traffic, being lightweight and ubiquitous, provides a rich data set for security analysis without imposing significant performance overhead or requiring intrusive endpoint modifications. Anomalous DNS patterns, such as malware attempting to communicate with command and control servers or users accessing spoofed domains, can signal early-stage attacks, enabling swift mitigation. Advanced DNS security solutions enhance this capability by integrating features such as real-time threat intelligence, anomaly detection, and robust encryption. Encrypting DNS queries, for instance, through protocols like DNS over HTTPS, DOH, or DNS over TLS, DOT, safeguards against interception and tampering particularly in vulnerable environments like public Wi-Fi networks. These measures ensure both the integrity of DNS transactions and the protection of user privacy. DNS security, beyond web navigation. The significance of DNS extends beyond website access to critical functions like email delivery and cloud service connectivity. Secure DNS configurations, such as domain-based message authentication, reporting, and conformance, DMARC-E, strengthen email security by preventing spoofing and phishing attempts. Similarly, DNS plays a pivotal role in ensuring seamless access to cloud-based applications, making its security integral to modern digital operations. DNS security, a strategic imperative. As digital ecosystems grow increasingly complex, DNS has evolved from a background service into a strategic control point. Its involvement in every facet of online activity, from transactional processing to cloud-based collaboration, underscores its critical importance. An unsecured DNS infrastructure exposes organizations to significant risks, while a fortified DNS framework offers a unique opportunity for early threat detection and prevention.